This topic will be about solving circumference problems. So if we're looking at this question, we can see Shane is building a curb around a circular fountain. The diameter of the fountain is 3.8 meters, so we're looking for the circumference. Circumference on a circle is the perimeter. So we're looking for the distance around the circle. So let's just get a makeshift circle, not the perfect one, but there it is. The diameter of that is told to be 3.8, and that's meters. Okay, and then we're looking for circumference. So circumference will be pi d, or pi times diameter, or 2 pi r, but in this case we don't have radius given, we have diameter. So we'll use pi times 3.8. So when we do that, we get 3.8 times, I'm going to use the pi button just to see the numbers. So we get that number. So that's if you're using pi. So we can see that if it wants 2 decimal places, then this 8 would round the 3 up to a 4. Okay. So that would be what's shown here. There's a 4 there. However, if we were to go through and use, if you don't have a pi button, multiply by 3.14, you would see that the 2 is not large enough to round the 3 up. So just be careful on if you're using a pi button or not in this case. So with the pi button, 11.94. Without the pi button, 11.93. So just go by based on what your question is telling you to do. Next scenario. Here we've got a person selling tires, and a customer has told her the circumference of the wheel rim on the tire, but Lila needs the diameter to get the size. So if the circumference is 47 inches, we're looking for diameter. Okay, so again, we use what we know from formulas, and we know that circumference is pi d. So if we use pi, we're looking for d. So we don't know that, but we do know circumference. It's 47. So we'll just put 47 here and leave the d variable as is because we don't know what that is yet. So we're going to try to solve for diameter. Okay, so we're going to isolate the d variable. So we're going to divide both sides by pi. So I'll just do that over here. Actually, should have enough room there. 47 over pi. And remember, if you divide by pi on one side, you must also divide by pi on the other side. D's divide out, giving you 1 times d. So diameter will equal 47 over pi. And then we'll just go back to the calculator for that one. So we're going to go 47. Again, I'll divide by pi with the pi button. So we can see 14.96. But that's kind of a weird number to give for a tire size. So your rounded number will be about 15. So that dot is about. Okay, because you're not going to go in and say, hey, I'd like a tire that is 14.96 inches. So we're going to round that to 15 inches. Okay, next one. We've got a cake decorator, Maggie. Her piping bag holds enough icing to make a line 4.6 meters long, and she wants to outline the top of the circular cake. So we're looking for the circumference of the cake first. Now we have the radius. Okay, so we're just going to keep that in mind as we're working through this one. Okay, so in this case, we know that circumference is pi d, but it's also 2 pi r. So then we'll just go and fill in what we know. 2 pi times the radius here of 16. Okay, and we'll just use the pi button again. Let's get our numbers. So 2 times pi times 16. That will give us about 100.5 roughly. And that will be centimeters. That'll be important for later. Part B. How many cakes like this one can Maggie outline with the piping bag? Okay, so the piping bag says it's 4.6 meters long. We've got enough icing to hold something to make it 4.6 meters long. So first thing we're going to do is take that 4.46 meters, and we're going to convert that to centimeters. So to go from a large unit to a small unit, we multiply. And in this case, by 2 spots. So 10 to the 2, which is 100. So we're going to multiply this by 100. So 460 centimeters is how much the piping bag can hold. And we want to know how many cakes you can do with that. Okay, so we know that this cake needs 100.5 centimeters. So we're going to do 460 divided by 100.5. So we'll go back to the calculator. So we'll take that 460 and divide by the non-rounded number of 100.5309,649. And we'll get about 4.57 roughly. Okay. So you can do about 4.5. So we're going to round that because again, it sounds weird to do or to ask for 4.57 of those. So this was 4.57. What was my number? 5757. Okay. So that one would round to 4.5 cake tops. Okay. Next one. Looking for information about the length of metal a gas pipe has. Okay, so in this case, this pipe has a circumference of 2.5 inches, which means the distance around the pipe is 2.5 inches long, and the pipe itself is 1/16 of an inch thick. Okay, you can divide that out to see it in decimal form as well. The gas fitter needs to know the inside diameter, so we're looking for this. So that dotted line there. So we need to know the inside diameter of the pipe to calculate the gas pressure. So the first part is saying, what is the total diameter, including the metal? So that would mean we're looking for all that. Okay. So when we work through that, keep in mind diameter. So we know circumference is pi d. And when we isolate for diameter, we just divide both sides by pi. Pi's divide out, leaving diameter equals circumference over pi. So in this case, diameter is what we're looking for. Circumference we know is 2.5 over pi. Okay, so again, we just go and calculate that. So 2.5 divided by, I use the pi button. So we get a number that's close to 0.8. So we can round this at the end, but just keep that number in the calculator. So for now, I'll just put 0.8. Okay, and that was inches. So that's the inside diameter. So this blue line. Okay, so then down here it says how much of the diameter is metal. So that's basically just here and there. So that's if one of the width is 1/16, then if we had to go all the way across, we would run into two places where there's a width of 1/16. So it's technically 2 of 1/16, which is 2/16, which is, let's just work that out here. 0.125. And again, that was in inches. Okay. So that's how much metal there actually was with the width going across, the width of the metal. And then it's asking what is the inside diameter of the pipe. Okay, so now you know the diameter all the way across was that. And the how much metal was actually in the width of the pipe is this much. So we just take the full distance across and subtract the amount of metal that was being used. So we go 0.8 minus 0.125 to give us about 0.675 inches. And that would be the inside diameter. Okay, so that would be, we're looking at the inside diameter right here, all the way across. Okay, so that's this number here. Okay, moving on to the track question. Here the scenario is Maria is wondering if the running track is longer or shorter than a kilometer. And we're told that each end is a semicircle. So then if we put this end together with that end, we should form a circle. And we know now that that circle has a diameter of 100. Okay, so we're looking for circumference in this case because we're talking about total length. We're going to go circumference again, which is pi d. We're looking at the ends first, then we can take into account the total length of this straight portion after. So right now we're just looking at the curved part. So circumference being pi times diameter of 100. Okay, so with pi, you'll get a number you'll have to round. Without pi, just 3.14 times 100. So again, we'll just go to the calculator and use the pi button. So we'll go second function pi times 100. Okay, there's that number. If you were using just the 3.14, then it would just be 314. And what was my other one there? 159, obviously. Okay, so we just keep that number in mind. And that was meters. So if we had to round this to the nearest whole number, we'll say 314 meters. Okay, because we're going to be comparing it. So moving to the next part, we want to know the total distance. So the total distance will take into account the two semicircles, which forms a full circle of 314 meters. And then we want to add the two portions that are 250 meters. So we'll figure out if this is going to be under or above the 1 kilometer in the question. So we'll just take the 314 and we will add 2 of the 250s, which is like adding 500. Okay, so we'll just have our 500. So this number the previous part, plus 500 is about that. Okay, so 814, 159. And again, that's in meters. So we want to take a look. We know that in 1 kilometer, there are, we want to move this into meters so we can compare them. Going from a large unit to a small unit, we know that we multiply, and in this case, we're multiplying by 1,000. So 1 times 1,000 is this. So in a kilometer, we have 1,000 meters, and we can see that we don't quite reach that 1,000 meter part. Again, if this was rounded to the nearest whole number, 814 meters. So this is clearly less than a kilometer in terms of the total length of the curved parts on the track. Curved plus straight parts.